Hey guys, welcome back. Let's talk about the last Aufgabe 5 of the Probeklausur. So in this question, they give us two vectors, v and w, and they're just going to ask us to find the norm or the length of one of the vectors, the cosinus, so the angle between the two vectors, and yeah, let's start with those. Okay, so part A. They asked for the norm of vector v. Here's the vector v, and they asked for the norm. The norm is another word for the length, okay? And before we start talking about the norm, I just want to bring some intuition to it. You can skip this part if you want to, but the length of vector, it's based on the Pythagoras theorem. Imagine you have a vector v like that, and it's 1, 1, okay? What's the length of v, right? 1, 1 means 1 on the x-axis plus 1 on the y-axis. So that's 1, 1. You have a triangle, right-angled triangle. And Pythagoras tells us this length is going to be, v, a squared plus b squared equals c squared. So c squared is going to be the root of a squared plus b squared. So the root of 1 squared plus 1 squared. And that's the idea here. Here we have a two-dimensional vector, but if you had, a three-dimensional vector, it would be the same. The root of each of the components squared. Okay, back to the question. Here we have our vector v, and they ask for the norm of v, right? Norm, this double line here, both sides, that's a notation for the norm. So the norm of v is just the square root of the squares of each of the components of v. That squared plus that squared plus that squared. Here, here, and here. And take out the square root. You get your final answer very quickly. In part B, they asked for the angle. Remember, they gave us two vectors, v and w. So if you imagine, let's say you had a no, that's not what I want. Imagine you had a vector v and vector w. That would be the angle between them, and that's what we want. And so there's a formula to find the angle, and it looks like this. The cosine of the angle is equal to the dot product of v and w divided by the product of the norms. What does dot product, what does norm mean? We'll see soon. But first, we know that we need the norm of v and the norm of w. So let's find, we know the norm of v from this part. So let's first find the norm of w, okay? Because we need it in formula. The norm of w is still the same. Each component of w squared, and take the square root of all that, you'll get the norm. Now you're ready to find the cosine. So apply the formula for the cosine. It's the dot product. The dot product means the first component of v times the first component of w. So that's the first component of w here times the first component of v, right? So first component of v times first component of w plus second component of v times second component of w plus third of v and third of w divided by the product of the norms. So that's 6 times 6 root 2. Okay, and then simplify. Then you get 1. Yeah, and then here is just simplify, 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 you get 1. So that's your cosine. That's your final answer. Yeah, next part. Next part, they give us, one moment, please. Okay. They give us a set of vectors, x1, x2, x3, and they ask us to apply Gram-Schmidt to these vectors. Well, what's Gram-Schmidt? It's just an algorithm, a process to create a set of orthogonal. Orthogonal means perpendicular, 90 degrees. Vectors out of a set of vectors that may not be orthogonal. So this vector and this vector and this vector, they might not be at 90 degrees to each other. We need to make them 90 degrees to each other. So we need to find this set right here. This set is 90 degrees to each other. If you apply the formula for the angle, so this formula up here, to any of these two vectors, you'll see that the angle is going to be 90 degrees. Okay. So first, you know, out of x2, x1, x2, x3, you need y1, y2, y3. Well, let's find them. So first we find y1. Y1 is just x1, always. The idea of Gram-Schmidt is we take one of these vectors, it can be any one of them, and we set that as our reference, and then we rotate the other vectors so that they are 90 degrees to this one, and this one is 90 degrees to this one as well as this one. Oh, sorry, I mean this one is 90 degrees to both of them. So if we set this one as our base, our reference, then y1 is just x1. Then we have to find y2. Well, y2, you know, there's a well-known formula to find the y2, to find the perpendicular. And the formula, I think I wrote it. Where did I write it? I forgot to write the formula, but anyways, it's here. Okay. So y2 is going to be x2. It's going to be this guy, but you need to rotate it out of y1. So it's going to be x2 minus y1 times the dot product of y1 and x2 and y1 in itself. Just remember this formula, okay? And so x2 is this minus y1, which we just found here. So y1 times the dot product. So the dot product is, you know, the entries time each other, right? y1 dot x2. So 2 times minus 4 is minus 8, plus 1 times minus 1 is minus 1, plus 1 times minus 3 is minus 3. Times the, so that's the top part, right? And then the dot product of the bottom part is just the entries, the corresponding entries, but it's y1 in itself. So it's 2 times 2 plus 1 times 1 plus 1 times 1. So it's 4 plus 1 plus 1. And this turns out into a scalar, right? Over here. You multiply this into that. So again, your x2 is still here, and that hasn't changed, minus this becomes that, right? And minus 2 times 2 is minus 2 times minus 2 is 4. Minus 2 times minus 1 is 2. It's 2 times minus 1 is 2 again. So then you add them together and you get your y2, and then you write it up here, okay? So you found your y2, now you just have to find your y3, and for y3, it's again, you start with x3, and then you rotate it out of y2 and y1. So x3 rotated out of y2 and rotated out of y1. Rotated out of y2, it means y2 times dot product y2 x3 divided by dot product y2 in itself, and then it's y1 times dot product y1 and x3 divided by dot product y1 itself. So it looks very similar to this one, right? But instead of starting with x2, we start with x3, and then we rotate it out of y2 as well as y1. And yeah, so apply the formula. That's x3 minus y2. The dot product turns out to be 0. Minus y1, that's y1. Okay, y1 is here. And times that dot product is 12. Dot product of y1 itself is 6, right? So you get this one minus 0. So essentially it's this one minus this one, which is here, right? 12 over 6 is 2, so 2 times 2 is 4. 2 times 1 is 1, 2 times 1 is 1, so 4, 2, 2. Then it's x2, so 3, 3, 3 minus 4, 2, 2 is minus 1, 1, 1. And then you found your minus 1, 1, 1. That's your orthogonal set. Boom. So that's your answer. y1, y2, y3. The last part is part D, and they give you a vector, and they tell you to find a vector that is perpendicular to this vector. And well, what do we know? We know that when two vectors are perpendicular to each other, their dot product is 0. Okay. So how do you do that? In effect, the explanation isn't here. If you want the explanation for why it works, please check the MIT lecture on orthogonal vectors. It's just a few minutes, but essentially, look, to find it, just, take each vector in here. So here we only have one vector, so just take it, write it as a line. So x plus 1x plus 2y is 3z, and set it to 0. And essentially, again, it's a Gauss. So if you look at this, you'll see that that's x, that's y, that's z, right? And again, we go back to our friend pivots and frees. The pivot is the first non-zero entry in its row. We only have one row, so that's our only pivot, and the rest must be the free columns. We have to write the pivots in terms of the frees. The pivot is simply minus 2y minus 3z. Now we're ready to build our vector. That's x, y, z. What's x? That's x. What's y? Y is y, because free variables always equal themselves. So y is y and z is z. But you can split this into a y and a z, right? So here we have minus 2y, 1y, and 0y. So minus 2y, 1y, and 0y. Then we have minus 3z, 0z, and 1z. So minus 3z, 0z, and 1z. So that's your final answer, minus 2, 1, 0, minus 3, 0, 1. And that's just what I said before. Write the pivot variable in terms of the free variables. Pivots, frees. So everything is in terms of the free variables. Thanks, guys.